Alright, so today we're going to look at using the law of sines to solve for missing sides and angles of non-right triangles. The law of sines allows us to calculate the length of missing sides and the degree of missing angles of non-right triangles. So when we have a non-right triangle, we can't use the Pythagorean theorem, we can't use SOHCAHTOA, we can't use our special right triangle rules because it's not a right triangle. So what we have to use is the law of sines. The law of sines, as you can see right here, it is set up as a little formula. It's a ratio. So if you notice, angle A matches up with side A, angle B with side B, angle C with side C, and they create this ratio, which we call the law of sines. Okay. So we're going to use this to work through some problems and find missing sides or angles, depending on what we're asked for. So in example 1, it asks us to find C. Now, obviously there's two C's here. There's one here, one here. We're actually looking for this one. If I was looking for this one, it would have to say find the measure of angle C, because this is an angle. But just know we're looking for the side. Okay, so I'm looking for this side. If I'm looking for this side, then I have to use the angle that goes with it, which is angle C, which is over here. And knowing that I'm going to use those two pieces, I'm obviously going to be using this part of that ratio. Okay, so I'm going to use the sine of angle C divided by side C. So then I need to look at the rest of my triangle and figure out what other piece of this ratio or formula or equation, however you want to put it, whatever else I can use. I have this angle A and I have side A. I don't know what either of them are, so they're really of no use to me, so I'm not going to use them. So I'm not going to use this piece of that formula, which means by default I have to use this piece. So I'm going to use the sine of B over side B. And if you look, I know what angle B is and I know what side B is. It's 7. So I'm going to plug everything in that I have into that formula. I have the sine of 50 degrees divided by side C equals the sine of 60 degrees divided by 7. And to solve this, I'm going to cross multiply. Boom, boom. 7 times the sine of 50 degrees equals C times the sine of 60 degrees. To get C by itself, I'm going to divide both sides by the sine of 60. So the sine of 60 is going to cancel out. And it leaves me with 7 times the sine of 50 degrees divided by the sine of 60 degrees equals C. From here, it's just a calculator problem. You can literally just pop it right in. 7 times the sine of 50 degrees divided by the sine of 60 degrees. And that's going to get us C equals 6.191. It doesn't tell us where to round, so we're just going to say 6.19. And that's our C value. In example 2, it asks us to find the measure of angle B. So angle B is here. I know that side B is over here, so I'm definitely going to use that. Then I also notice that I have this A and this side over here. This is side little a. And if I plug everything in, I have the sine of b divided by 6 equals the sine of 120 divided by 15. Again, to solve, I'm going to cross multiply, and I have 15 times the sine of b equals 6 times the sine of 120. To get b by itself, I'm going to start by just dividing both sides by 15. And I have the sine of b equals 6 times the sine of 120 over 15. To get b by itself, I have to get rid of this sign. I need to move it over here. If I'm moving it over, I can't do it by dividing because it's not being multiplied. I have to take the inverse. So b is going to equal the inverse sine of 6 times the sine of 120 divided by 15. And if you plug that into your calculator, which you definitely can do, you're going to end up with 6 times the sine 20 divided by 15, 20.267. So B is going to be about 20.3 degrees. And that is how you use the law of sines to find missing sides and angles of non-right triangles.